Good morning, students. Today we will discuss problems related on the topic the radioactivity and the radioactive decay law. Right. So the first problem. Calculate the half-life and mean life of radius 226 of activity 1 Curie given mass of radius is 226 gram 226 gram of radius consists of 6.023 into 10 to the power of 23 atoms or nuclei, right? So this is the question. Calculate the half-life and mean life of radius 226 of activity. They given the activity is 1 Curie, right? So the first given is activity, right? So if you written here given, so activity denoted by R, that is equals to 1 Curie. So the SI unit of activity is becquerel. So 1 Curie is 1 into 3.7 into 10 to the power of 10 becquerel, right? So first we need to convert Curie into becquerel. That is 1 Curie is 3.7 into 10 to the power of 10. So that's why 1 into 3.7 we get the activity in the form of SI unit, right? So the given mass of the radius is how much? That is 226 grams, right? So mass that is equals to 226 gram. Here we need to convert from gram to kgs, right? So 1 gram is equals to 10 to the power of minus 3 kg. So it becomes 226 into 10 to the power of minus 3 kg, right? So next here we need to find the half-life and mean life, right? To find half-life, that is T half, and mean life, that is tau, right? So here they given mass of the radius, that is 226 gram, consists of how many number of atoms? That is 6.023 into 10 to the power of 23. So this is the principle that is from Avogadro's principle. So as you already studied in the chemistry, so one Avogadro number. So this is the Avogadro number 6.023 into 10 to the power of 23, right? So we have the formula, that is relation between the activity and the half-life, right? So from this we have activity R is equals to lambda n, where n is the number of the nuclei, but we don't know the value of lambda, right? So from the half-life we know that T half is equals to 0.693 whole divided by lambda. So this is the relation between the half-life and to the decay constant, right? So here we need lambda, right? So here lambda is equals to 0.693 divided by T half, right? Now substitute this lambda here, that is R is equals to 0.693 divided by T half into n. So here we are going to find T half, right? So they given R value, we need to find T half and we need to find the n value, right? So for n we need to find, for the mass this much having consists of the number of atoms 6.023. That means the number of the nuclei, right? So the number of the nuclei is how much? That is 226 into 10 to the power of minus 3, right? So now T half is equals to 0.693 divided by R into N, right? So here 1 gram consists of 6.023 into 10 to the power of 23 atoms, and here we have the mass of 226 grams, right? So for the total 226 grams, the number of nuclei present is 6. That is, here we will substitute 0.693 divided by activity is 3.7 into 10 to the power of 10 into n value is, that is 6.023 into 10 to the power of 23 whole divided by 226. Right, so this is the atoms which is present in 1 gram. So here they given 226 grams. So the number of nuclei present, that is n value is 6.023 into 10 to the power of 23 divided by 226, right? So if we simplify all these values, we get the value T half, that is equals to 4.99 into 10 to the power of 10 second, right? So 10 to the power of 10 second. So here we need to convert the time period from seconds to hours, right? So this is in second. So if we need to convert this to second, so in terms of hours means we need to divide 4.99 into 10 to the power of 10 whole divided by 365 into 24 into 16 into 60, right? So 60 is the seconds, 60 minutes, 24 hours and 365 days. So if we divide 4 by this, we get in terms of years, right? So if we simplify this value, we get T half, that is 1583 year. 1583 year. So either we can stop up to here 4.99 into 10 to the power of 10 seconds, or we can stop here by calculating in terms of year. So that means only 226 gram, only small amount of the gram, this much has to disintegrate its half time, that is it takes 1583 years to reduce its nuclei, that is half of its nuclei. For example, if this mass has 200 nuclei, then the time required to reduce to half, that means to reduce 100 nuclei means it takes 1583 years, right? So next we need to find tau, right? So we have for that mean length tau, that is equals to 1 divided by lambda, that is decay constant, right? So here we have lambda is equals to 0.693 divided by T half, tau is equals to 1 divided by 0.693 T half, right? So T half goes to the numerator, then T half divided by 0.693, right? So here we have the value half-life, that is 1583 year divided by 0.693, right? So here we get the value 1583 divided by 0.693, that is 2284 year. right? While solving the problems, you need calci. By using calci, you can simplify these values, right? So the main important formula here is the activity starts from activity R is equals to lambda N. So here we don't know the value of the decay constant, right? So here we need to find the T half. So that's why we write the relation T half is equals to 0.693 by lambda. So in place of lambda, we are replacing 0.693 by T half. Then we know the value of R and we know the value of N. Then we can find the T half, right? So you can stop up to here in terms of seconds, or you can stop by converting it into the years, right? So next. So second one, find the activity in curie of 1 gram of radon 222 whose half-life is 3.825 days. Avogadro number 6.023 into 10 to the power of 23 given 1 curie, that is equals to 3.7 into 10 to the power of 10 becquerel. Right, so here we need to find the activity. In the last problem, they have given the activity, and from that we find the half-life and mean life. So here we need to find the activity. They given half-life, right? So T half they given, that is 3.825 days. So on the given the Avogadro number, right? So here we need to find mass, that is the number of nuclei present in 1 gram, right? So if I write here given half-life, they given T half, that is 3.825 days. So the SI unit of the time is in seconds. So we need to convert this days in seconds, right? So 3.6 3.825 into 1 day has 24 hours. So each hour has 60 minutes. So each minute has 60 seconds, right? So converting from days into second, right? So here 3.825 days into 24 hours, 60 minutes, 60 seconds, right? So if we simplify that value, we get that is equals to 3.380 into 10 to the power of 5 seconds. the next, they given 1 curie. 1 curie, that is equals to 3.7 into 10 to the power of 10 becquerel. And so here from Avogadro principle, so around 226 consists of 6.023 into 10 to the power of 23 atoms or nuclei, right? So here we need to find 1 gram, right? So 1 gram consists of, that is n, that is equals to 6.023 into 10 to the power of 23 divided by 226. That is, right on 226 means it consists of 226 grams. So 226 grams consists of 6.023 into 10 to the power of 23 atoms. So here we need to find in 1 gram. So from 226 we need only 1 gram. That's why, so 6.023 divided by 226 we get the value of n, right? So here to find the activity R, right? So here we are going to find the activity, right? So we have the formula activity R is equals to lambda n, right? Where lambda is the decay constant. So here lambda is equals to 0.693 divided by T half, the relation between half-life and lambda, decay constant, right? So we have the half-life, right? So now substitute here, lambda is 0.693 divided by T half into n. Activity R is equals to 0.693 by T half into n, that is equals to 0.693 divided by, so T half we are getting 3.380 into 10 to the power of 5 seconds into n value is 6.023 into 10 to the power of 23 divided by 226, right? Now if we simplify this we get 1.583 5.689 into 10 to the power of 25 becquerel, right? So if they ask find the activity, then this is the final answer, that is 5.689 into 10 to the power of 25 becquerel. But here they ask the activity in terms of curie, so we need to convert this value from becquerel to curie, right? So here we have 1 curie is equals to 3.7 into 10 to the power of 10 becquerel, then 1 becquerel is equals to, from this we can write 1 becquerel, that is equals to 1 divided by 3.7 into 10 to the power of 10 curie, right? So that is converting from curie to becquerel and becquerel to curie, right? So 1 becquerel is equals to 1 divided by 3.7 into 10 to the power of 10 curie, right? So here we have the becquerel. So in place of becquerel, we need to substitute this value. Then we get the activity in terms of curie, right? So here I will write here R value is 5.689 into 10 to the power of 25. So in place of this becquerel unit, we have the value that is converting from becquerel to curie, that is 1 divided by 3.7 into 10 to the power of 10 curie, right? So now if we divide 5.689 divided by 3.7, then we get the value 1.1 1.583 into 10 to the power of 15, 25 minus 10. So it goes to the numerator, it becomes minus 10. So 25 minus 10, it becomes 15 curie. So this is the final answer. R is equals to 1.583 into 10 to the power of 15 curie, right? So if they ask only to find the activity R, then this one is the last final answer, right? 5.689 into 10 to the power of 25 becquerel. So here we need to observe this one. They ask the activity in terms of curie, then we need to convert the unit becquerel into curie, right? So this is the given half-life. Then from the half-life we are finding the activity. So we have the simple formula R is equals to lambda n, and we have the formula lambda is equals to 0.693 by T of, or T of is equals to 0.693 by lambda, right? So next, third problem. Determine the mass of Na22 which has an activity 5 millicurie. So M represents milli, 5 millicurie. Half-life of Na22 is 2.6 years. So the given Avogadro number, that is equals to 6.023 into 10 to the power of 23 atoms or nucleus. So here we need to find the mass, the given activity, right? So activity they given, and we need to find the mass. So for which mass the activity is 5 millicurie, and the given half-life, that is 2.6 years, right? So first, if you write here given, so the given activity is R, that is equals to 5 millicurie, that is equals to 5 into 10 to the power of minus 3. Milli is 10 to the power of minus 3, and the SI unit of activity is becquerel. So we are converting from curie to becquerel. So 1 curie is 3.7 into 10 to the power of 10 becquerel, right? So this is equals to 5 sevens are 35, 15 plus 3, 18.5 into 10 to the power of minus 3 plus 10, that is plus 7 becquerel, right? So this gives the activity R value is 18.5 into 10 to the power of 7 becquerel. Next, the given half-life, right? So T half is how much? 2.6 years. So the SI unit of time period is second. So converting from years to second, that is 2.6 into 1 year. We have 365 days. Into each day we need to find the number of nuclei which are present in this 22 gram, right? So N22 represents mass number, A represents mass. So that means A value is 22. That means the mass number which is present in that is 22 grams, right? So from that we have the formula R is equals to lambda N. From this we are going to find the number of atoms which are present in this nucleus, right? So on that sample sodium, right? So R value we have, and we know lambda is equals to 0.693 by T half, right? Now substituting here R is equals to 0.693 divided by T half into N, right? So we know R value and we know T half, so N that is equals to R into T half divided by 0.693, that is equals to, so R value is 18.5 into 10 to the power of 7 into 81993600 whole divided by 0.693, right? So if we simplify the value, we getting 2.189 into 10 to the power of 16 atoms, right? That means, so 22 gram mass of sodium consists of 2189 into 10 to the power of 16 atoms, right? So from this, yeah, mass of 6.023 into 10 to the power of 23 atoms is equals to 22 gram, right? So this consists of how many number of atoms? This is from the Avogadro principle. So as already discussed that topic in chemistry, right? So the sodium 22 consisting of 6.023 into 10 to the power of 23 atoms. So here they given the activity of 5 millicurie. So from the activity we are finding the number of atoms present in the nucleus is 2.189 into 10 to the power of 16 atoms, right? So here we need to find the mass which consists of this number of atoms, right? So from here, mass of 2.189 into 10 to the power of 16 atoms, that is equals to, we don't know that one is x gram, right? So 6.023 into 10 to the power of 23 atoms having the mass 22 grams. So here 2.189 into 10 to the power of 16 atoms having the mass x, right? So we need to find x, right? So that is x is equals to 6.023 into 10 to the power of 23 divided by 2.189, right? So cross multiplying these values, we get 2.189 into 10 to the power of 16 divided by 6.023 into 10 to the power of 23, right? So if we simplify, we get the value 7.99 into 10 to the power of 16 minus 23, that is minus 17. The value minus 10 grams. So x value is 7.99 into 10 to the power of minus 10 grams. So this much of mass consists of 2.189 into 10 to the power of 16 atoms, right? So that can be written be 6.023 into 10 to the power of 23, that is equals to 22. This one is the atoms, that is equals to 22 grams. And here 2.189 into 10 to the power of 16, that is equals to x gram. So if we cross multiply these two, so x into 6.023 into 10 to the power of 23, that is equals to 22 into 22 into 2.189 into 10 to the power of 16, right? So here x is equals to 22 into 2.189 into 10 to the power of 6 whole divided by 6.023 into 10 to the power of 23, right? So here we are getting x is equals to 7.88 into 10 to the power of minus 17 gram. Because here 22 is in grams, so here the final answer is also in grams, right? Otherwise, cancel this one and follow here this one. So it's 4 problems. So this passed in the last year 2019. Half-life of uranium 238 undergoing alpha decay is 4.5 into 10 to the power of 9 years. What is the activity of 1 gram of uranium 238, that is U-238 sample? So in 2019 they asked this question. So they given half-life, we need to find the activity, right? So here if we write the given half-life, that is T half, that is equals to 4.5 into 10 to the power of 9 year, converting from year to second, that is 4.5 into 10 to the power of 9 into 365 into 24 into 60 into 60 seconds, right? Next, so we need to find the activity of 1 gram, that is of the uranium 238 sample. That means we need to find R. So as we know the formula, activity R, that is equals to lambda n, right? And also we know the value of lambda, that is equals to 0.693 divided by T half, right? So substituting here 0.693 divided by T half into n, right? So we need to find only 1 gram, the activity which is done by the mass 1 gram, right? So from Avogadro's principle, right? So uranium 238 has mass, that is 238 consists of 6.023 into 10 to the power of 23 atoms, right? So uranium 238 has a mass that is equals to, it has a mass 238 and it consists of atoms 6.023 into 10 to the power of 23 atoms. So here we need only 1 gram, right? So for 1 gram, that is equals to, so the number of atoms which are present in 1 gram, that is equals to 6.023 into 10 to the power of 23 divided by 238, right? So that gives what? N. N is equals to 6.023 into 10 to the power of 23 divided by 238. Now substituting here, right? 0.693 divided by T half into 6.023 into 10 to the power of 23 divided by 238, right? So here 0.693 divided by T half. So we need to simplify these terms, that is, I will write as 4.5 into 10 to the power of 9 into 365 into 60 into 24 into 60 into 6.023 into 10 to the power of 23 divided by 238. So we get the answer 1.23 into 10 to the power of 4 becquerel. 10 to the power of 4 becquerel. Right? So this one is the final answer. So this problem they asked for 5 marks. So very simple. We have to remember this formula R is equals to lambda n, and here the lambda is equals to 0.693 by T half. They given T half and we need to find the n value, that is from Avogadro's principle, U38 having the mass 238 grams, right? So we need only 1 gram, right? So for 1 gram we need to divide this 238 here. So this gives the number of atoms which are present in 1 gram, that is number of atoms or number of nuclei, right? So n value is 6.023 into 10 to the power of 23 by 238. So substituting here and simplify, we get the value 1.23 into 10 to the power of 4 becquerel. So this question they are asking for 5 marks, so simplification is very important. So don't directly simplify all the values in the calci and write like this, right? So you have to mention in the each step. First you have to multiply these two, then first here simplify these values and dividing those values. After that you have to write like this. Don't write in single step or 2 steps, right? So this one they asked in the last year, right? So move on to the next problem. So these are the problems in activity. So we have only the formulas, that is R is equals to in radioactivity we have R is equals to lambda n and lambda is equals to 0.693 divided by T half, and we one more main line, that is T is equals to 1 by lambda. Only we have these 3 formulas, right? So either they ask for to find the activity giving the decay constant or they giving the half-life, right? So if they given half-life, then from this half-life we can find the decay constant, we can find the mean life, and we can find the radioactivity, right? So here we need to find option one is we need to find the activity, and they ask for mass to find the mass which consists of the atoms, right? So and they may ask for the mean like tau, right? Only we have these three formulas in radioactivity, right? So on this topic we solved four problems. So all are different problems, right? So almost nearer to one another. If they given, they may change the value of this one or this one, and then they find R and decay constant lambda, right? So move on to the next problem, that is from binding energy. So this year they ask for 5 marks from this topic. So this one, the problem which is asked this year, right? So a copper coin has a mass of 63 grams. Calculate the nuclear energy. Calculate the nuclear energy that would be required to separate all the neutrons and protons from each other. The coin is entirely made of 63 Cu29 atoms, right? The given mass of 63 to 20 Cu atom, that is equals to 62.92960 U, and mass of proton, that is equals to 1.00727 U, and next mass of neutron, that is equals to 10866 U, and Avogadro number, that is equals to 6.023 into 10 to the power of 23 ounces. Right, so here the given one copper coin, right? So this copper coin consists of the atoms, that is having the mass, that is 63 grams, right? So this consists of both protons plus neutrons, right? So here we are going to break these protons and neutrons into separate, that is protons plus neutrons, right? So we are breaking this copper into separate nuclei, that is protons, which consist of only the protons, and here we have only the neutrons, right? So for that we require some energy, right? So that energy is what? That is the binding energy, right? So that one we have the formula EB, that is equals to delta M C square, right? So we have this nucleus consisting of protons and neutrons having the mass 63 grams. So here we need to divide So this one need to separate the protons and neutrons, right? So for that we have required energy. So that energy we are going to find out. That energy is the binding energy, right? So in the other form we have delta M into 961 mega electron volt, right? Converting from joules energy. This is in the form of joules. So converting this joules in terms of mega electron volt, because the energy which we are measuring in this chapter, that is in mega electron, that is in the electron volt. So we have delta M into 9.61 mega electron volt. So this value is constant. So first we need to find this delta M. So delta M is the mass defect. First we need to find the mass defect, then we can find the energy which is required to break the nucleus of the copper coin, right? So for that we have mass defect delta M. The formula mass defect delta M, that is equals to Z into MP plus A minus Z into Mn minus M, that is mass. That one is the rest mass. They given the rest mass is 62.9290, right? So here they given Z. So Z is how much? That is 29, right? So that is delta M, that is equals to Z value is 29 into mass of the protons, that is 1.00727 plus here A value is how much? That is 63. 63 minus Z value is 29, right? So mass of the neutron is 1.00866 minus mass, that is the rest mass M, that they given 62.92960 U. Right? Now if you simplify this one, that gives 29 point, first multiply these two values, 29 into 1.009, that gives 29.21083 plus here 63 minus 29, that is equals to 34. 34 into 1.00866, so that gives 34.29444. So don't round off these values. So here we have 29 and 1.00727 is the lesser value. So don't round off it to 1, right? So each and every decimal point is very important here, right? Minus 62.92960, right? So here now we need to add these two, 29 plus 34. 63 minus 62, so that gives almost 0.57 567 U. Once you simplify by using the calculus, right? So this gives the rest mass delta M, right? So we need to find the binding energy, right? So the binding energy EB is equals to delta M into that value is 931.5. The standard value of 931.5, right? So here delta M value they given 0.57567 into 931.5. So we get the binding energy 535.94 mega electron volt. So this much of energy is required to break the copper nucleus into separate protons and neutrons, right? So Very simple. This asked for 5 marks. This year they asked this question for 5 marks, right? So we need to remember this formula. Mass defect delta M, and we need to remember this and the value 931.5. Right? So next. So this is asked in 2015 or 14, right? So calculate mass defect and specific binding energy, of 7n14, the rest mass of nitrogen, nucleus 14.00307 U, and the given mass of the proton MP, that is equals to 1.00727 U, and mass of the neutron, that is equals to 1.00866 U, right? So here we need to find the mass defect and specific binding energy, that is binding energy per nucleon, right? So from that first, if we need to find the mass defect, that is delta M, that is equals to Z into MP plus A minus Z into Mn minus M, right? So here the Z value is how much? That is 7, right? 7 into 1.00727 plus A minus Z, that is 14 minus 7. 14 minus 7 into 1.00866 minus the rest mass they given 14.00307 U, right? So if we simplify this one, we get the value 7.05487 plus here 14 minus 7 is 7. So 7 into 1.00866. So that one we get 7.06089 minus 14.00307, right? So the mass defect we are getting 0.11243 U. That is the mass defect delta, right? So next we need to find the binding energy EB is equals to delta M into 931.5, right? So delta M is 0.11243 into 931.5, right? So that is equals to 104.7285 mega electron volt. So this one is the binding energy, right? So but they ask for specific binding energy, right? So specific binding energy, that is EBM, that is equals to binding energy divided by mass number, EB divided by A, right? So here we get the EB value, that is equals to 104.7285 divided by the mass number is how much here? 14, right? So we get the specific binding energy 104.7285 divided by 14. We get the value 7.804 mega electron volt. This gives the specific binding energy. Let's take this one as one. So take this one as homework for oxygen, right? So this one is also asked in once 2014 or 16. They asked this problem for oxygen 860, right? So take this one as also homework. The half-life of 38 is 90 is 28 years. So here they given the half-life and we need to find what is the disintegration rate of 15 mg, right? So here first we need to convert the 15 mg into the number of atoms which are present in 90 is 6.023 into 10 to the power of 23 atoms. So out of 90 grams, we require only 50 grams. So we need to find the 15 grams. That is 15 grams consists of 6.023 divided by 90. Then we get the number of atoms which are present in the 15 grams, right? So they given half-life 28 years. So here, what is disintegration rate is nothing but radioactivity. We need to find R, right? So disintegration rate, or we call that one as also decay rate, right? Or we can call this one as decay rate, or we call this one as activity, right? That means we need to find R, right? So once practice these problems, because these are very important and they ask for 5 marks. Easy problems because all the data they given directly we need to substitute in the formula and simplify, right? Thank you. Doubt you can answer.